Multi-year decadal prediction aims to provide surface climate information, but so far, most of the predictability work on these timescales have mainly focused on the ocean properties. In this study, I want to develop a new tool to quantify decadal predictability in the daily surface climate fields. Specifically, I want to address these two questions. How large is the force predictability in daily surface air temperature and precipitation in the near term? How significant is the force predictability compared to that produced by ENSO? To do that, I took advantage of the multimodal large ensemble repository. To quantify predictability, I used relative entropy from information theory. It's often called KL divergence. It's a measure of how different one probability distribution P is from the reference distribution Q. It's widely used in machine learning as a cost function when training classifiers, but it is still relatively new to our field. In our earlier work, we used this derived expression for n-dimensional Gaussian distribution to calculate KL divergence, because for those studies, we were focusing on annual mean subsurface temperature, or AMOG, and we assumed those variables were roughly Gaussian. This time, I want to try this original non-parametric definition, and I prefer Jensen-Shannon divergence over KLD. In my view, it is a better metric because it's symmetric and is bounded by 0 and 1. 0 means the two distributions are identical, and 1 means there's no similarity. Now let's look at how much information we can get from ENSO prediction. From the CESM1 control run, I picked 280 El Niño and 240 La Niña events. The top panel shows the DGF seasonal mean difference in TAS, and the bottom panel shows the GSD in daily data. Regions with the largest change in the mean do not coincide with regions with the largest change in probability distribution. For example, let's look at two regions, Alaska and the Equatorial Pacific. They both have roughly 3-degree change in the mean, but when you look at the probability distribution change, top for Alaska and the bottom for the Equatorial Pacific, red for El Niño, blue for La Niña. The distributions are totally different with the GSD equal to 0.099 in the Equatorial Pacific, while they are quite similar in Alaska with the GSD equals to 0.02. Although for research, both PDF changes have significant scientific values, but they have quite different implications for prediction. Now let's switch to the multimodal large ensemble. Since the force predictability increases with time, let's just look at the GSD at the end of the 30-year study period centered in 2030. And the plot on the right shows how different the 5-year probability distribution is from the base climate. Aside from some model-to-model differences, all 6 models show the largest change in the probability distribution, or the largest information gain, or force predictability in the tropics. This is quite different from the change in the mean, which highlights polar amplification. I also did the calculation for precipitation, but due to the time limit, now I have to jump to the second question. How significant is the force predictability compared to that produced by ENSO? This plot shows the information gain average in the continental US in TAS, solid, and precipitation dashed from the 6 large ensembles. They are all from the daily data. The 2 horizontal bars show the amount of information in ENSO seasonal mean TAS and precip. I should warn you that these bars are from ENSO seasonal mean TAS and precip, not daily data. And information in the daily data is much lower. I just want to use seasonal mean ENSO information as a threshold for operational forecasts. Well, the precip curves are pretty flat, right? Even for TAS, there's not that much information in daily data in the first 1 or 2 decades compared to the ENSO information. Of course, we can enhance the information by temporal averaging or perhaps by increasing ensemble size. For whatever decision we want to make, relative entropy can provide a cost function to gauge how far our research is from operation. Thank you very much.